Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to create our own web browser by adding HTTP web page processing. This was our application at the end of the last video. We have the basics of a Lite browser. Currently, this Lite browser will only view static web pages on the local machine. What we're going to add today is the ability for this web browser to actually look at web pages on an actual web server. But before we start on those changes, we need to fix one bug which has appeared. On our index 2 page, we have a number of links. If we open up page 1, open up page 2, and open up page 3. Each of these pages occupies a separate tab on the browser. If we then go to page 2, right-click and close the tab down. If we then go back to the index page and click on page 2 once more, it should add it as an extra tab between demo page 3 and the plus tab. However, it's adding to the right of the plus tab, which will break our ability to add new pages. So this is a bug we need to fix first of all. So something appears to be going wrong with the event when we delete a web page. So let's have a look at the code. The problem is in the remove tab history function. In the remove tab history function, we're doing a number of deletes from arrays, from the URLs array, the target names array, and the latest slot array. However, what we're not deleting from is the tab handles array. The tab handles array contains the handle of each of our tabs. When a tab is deleted, we want to delete that entry from the array as well. Failure to delete the entry from the tab handles array is what's causing our problem. If we now run our application once more, and we open up the 3 pages we opened before, and we go to page 2, delete that tab completely, go back to our index page and add page 2 again. It's now being added before the plus tab. So it's now been added in the correct position. So we have cured that particular problem. Now we can start looking at making changes so we can connect to a web server. In order to do that, I've taken all the HTML pages we have previously been using and I've put them onto another computer. We've set up the Abyss web server on that computer, which we've covered in previous videos. If we go into a Chrome browser and attempt to connect to this new computer, we can see this is our page coming from an HTTP web server. So with our web server all set up, we're now ready to start making some changes to our application to allow us to connect to this server. One of the things that web browsers use to speed up their browsing is the use of a cache. And this is what we'll set up first. We will set up a local cache folder. In order to make it visible to our application, we're going to set this up in the root of our application directory. And we're going to call this folder, quite simply, cache. We're setting it up using a string constant called cache folder. And we're going to make a minor change to the pbmain function to test for the presence of this folder and to create the folder should it not exist. So we will test for the presence of this folder using the isFolder function inbuilt to PowerBasic. If this returns false, then the folder does not exist, and we can use the make directory command to create the folder. If we run our application now, we should find in the root of our folder we now have a new folder called cache, which we do indeed, and this is currently empty. When we attach to a web server and pull down the files, the HTML files and any images, this is a folder into which we will place them. So the logic we have in our application so far quite happily handles HTML files in a local drive. When the user keys in a URL at the top of our browser, at the moment they are keying in a local path. So we need to be able to detect whether this is a local path or whether this is a URL. There are a number of ways of actually doing this, but for today's video we're going to be looking for the beginning of the string starting HTTP. We will not at the moment be handling HTTPS secured web pages, we'll just be handling HTTP. So we have logic in the application already which renders HTML to our graphics control. So if we look first of all at the render the HTML function, we're going to create a new local variable within this function called isWebPage. This will be true or false variable. True if the URL is a website and false if it's a local file. And further down that function where we load the HTML page, we're going to pass this value as a parameter, as it will be used through the rest of the application. So there is our new parameter to the load HTML page, long is web page. And further down the code where we are rendering the HTML tags, we will pass the value of that variable to that function also. So now we have at least two functions to amend to take this new parameter. So let's first go to the load HTML page function. And we'll add in the new parameter to its parameters list, isWebPage. And the purpose of this function currently is to work out if the file is a web page or is it a local file. So we've now put a little bit of logic in here to test the first four characters of the URL. If the first four characters are HTTP, then we are considering it as being loaded from a web server. Otherwise, we're going to keep the existing code in place to use the binary file as string to load it in from the local drive. And we are populating the isWebPage variable, either with true if it's coming from a web server and false if it's coming from a local drive. So we have now referenced a new function called getWebPage, taking a single parameter of the URL. This is the function that's going to go to our web page and load it off the web server. So we will now go and create this new function. And here is our new function taking its single parameter of the URL. We have created a number of local variables which are going to be used to manipulate data so we can load our web page. First of all, we will determine the site we're going to connect to using the parse command. And then we will pick up the file name as the last element of that URL. Next, we're going to pick up the local file path, which is where we're going to put our cached files. And we're going to use an API routine later on in the code, so we're going to set up an ASCII-Z version of the local file path. As connecting to an HTTP website is going to have its own cache going, we need to delete any URL cache entry we have for that to ensure we're getting the most recent version of the file. So we're going to call an API function called delete URL cache entry. We'll create the reference to this API call at the beginning of the application later on. After we've deleted the cache entry, we need to actually then check to see if the file exists in our local cache path. And if it is, we will delete that file. So we will test using the isFile command, and we will use the kill command to delete it should it exist. Next, we want to download the file from the HTTP website. So we're going to use some TCP commands here. So first of all, we're picking up the next available file handle using the free file command. And now we're going to start using TCP commands. First of all, a TCP open on HTTP at our URL site, which in this case is Odroid 006. And we're giving it a 60,000 millisecond timeout. Should there be any error opening in this, we're beeping and exiting the function immediately. If we do manage a connection, we're then using the TCP print command to send a GET message to our URL. This will then allow us to download data blocks until no more data blocks for the file requested are available. And within this loop, we're building up the HTML variable, which is a string variable to hold all the data from the web page. And we're looping while this is true. And we have no error. Once there is no more data to get from the website, we're closing down the TCP connection. Having populated the HTML variable, we can then save this to our local cache path. However, we want to remove the HTTP header from the received data. And then we're opening the local file path, which is our cache folder for binary access, and putting the data in our HTML variable into that file. So this will be our local cache, which we can use later. And the output of this function is the HTML text. The purpose of this function is to download the web page itself. We will download any images referenced in this file at a later point, but this will give us the file itself. So let's now go back to the beginning of our application and set up this API call. And here is the function set up for our API call. So we're calling the delete URL cache entry, and if the Unicode constant is defined, we're calling the wide version of this URL, otherwise we're calling the standard ANSI one. And we're declaring these two functions here, which are part of the Windows operating system. Now that we have that set up, we can now amend the second function we added the isWebPage to, the render HTML tags. So there is our isWebPage parameter added to its parameters list. And the second change we need to make to this function is where we're handling image tags. So we go down to the image case statement. Within this case statement is where we handle images, and there's a function call to display image. And we're going to pass on the isWeb parameter to that one as well. This will allow us in this one function to handle both local images and images coming from a web server. So let's now go to the display image function. And here we have now added our new parameter to the list of parameters that function is currently taking. So I'm going to add a new local variable to allow us to keep track of whether the image has been loaded successfully or not. And this will be another boolean, either true if it's loaded successfully or false if it is not. So we need to make some more changes to this section of code. Currently it's calling the load image file function, which is dedicated to loading an image file from the local machine. So we have to test the isWebPage variable. If this is true, we know it's coming from a web page. Otherwise, we can use the existing functionality. So having tested isWebPage, we can now pick up the full HTML path from our URLs. This is the functionality we used for local files. The difference here is we're now calling a new function called loading image from web to cache. This function will take the image from the web server and save it to the local cache. Once it's in the local cache, it is then on the local machine, and the existing functionality to load the image file will work quite nicely. All we need to do is to populate the source and the path, in this case coming from the cache folder. And the return from the load image file is populating our image loaded variable, which will either be a true or a false. We can then test the value of that variable before we attach to our graphics command and copy the bitmap in. So we now have a new function to create called load image from web to cache. So here is the skeleton of our new function, taking its two parameters. First of all, the URL site, and secondly, the file name. The structure of this function will be very similar to that which we used to get the HTML page. We're setting up some local variables to handle the loading of this file. So firstly, we're getting the site and the file to load as we did before. Next, we're working out the location to put the file on the local PC, in this case into the cache folder. Next, we're calling the API function delete URL cache entry. And we're also killing any file of that name in the local cache. Next, we want to download the file. Again, opening using a TCP open command for HTTP. And we're again getting the data blocks. This could probably be a common function, as it's very similar to the one that downloads the web page. The only difference is this one does not return the HTML as a return of the function. So now that we have this code in place, have we done enough to allow us to actually view web pages? Let's try running the application and see how it goes. Well, we've put a URL in for Odroid 006 on the index2 page, and we're getting that index page coming up quite happily. If we click on one of the images, we get a second tab up, again populated from the website. And if we go to one of the ones further down, for example, page 6 loads quite happily. And if we try page 7, it also loads quite happily. So we now appear to be getting all the data from our website. Let's just double check and have a look at our cache folder. There is our cache folder, and there are the files sitting quite happily within it. So in summary, what we've achieved today, our Lite Web Browser is now capable of communicating with an actual web server. It will download web pages and the images contained with those web pages to a local cache folder. Then, having achieved that, it can then render the web page on each of the tabs the user has selected. So we have taken a major step forward with our Lite browser, in that it now performs as a web server browser. Hopefully you'll find some of this code useful in your own applications, but that's it for today. Thank you for watching.